Today we're going to be interpreting graphs of distributions. We'll be determining the symmetry and modality of histograms, as well as the skew of histograms and box plots. Okay, so let's get on with the fun stuff then. So we've got two histograms here to interpret, and we'll start off by taking a look at the one on the left. We'll call this one number 1. So if we take a look, we see that we have a vertical axis, that's our frequency, and a horizontal axis, that's our variable. I've abbreviated both just for the sake of time. So if we're throwing a party, let's say this graph represents, well, this axis would represent people, and this one would represent, let's call it pizza. So slices of pizza. So we would interpret this first bar over here then as 4 people took 0 slices of pizza. Maybe they just weren't hungry. So then this next bar over here would be interpreted as 5 people, right in the middle here. 5 people took 1 slice of pizza, and so on and so forth, right on down the line. So in this histogram, it's important to note that our variable axis is discrete categories, not continuous data. So each one of these is a category: 0 slices of pizza, 1 slice, 2 slice, so on and so forth. So let's just quickly undo these. Oops. Alright. And so the next thing we have to do is find some symmetry. So our range for this graph is we have some observations in the category 6, which is our highest, and we subtract our lowest category, which is 0. So our range is 6. We have that, and we have tells us that our line of symmetry, LOS, should be at 3. So let's just go ahead and draw this real quick. Now we can see that it's not perfectly symmetrical on each side of this line, right? But it's pretty uniformly distributed right across, right? Distributed fairly evenly right across the graph. So we're going to go ahead and call this symmetrical. Symmetrical. Okay. So how about our modes? Well, I kind of gave it away there by using plural, but we've got a couple different modes. We've got one at 1, we've got one at 3, one at 4, and one at 6. So our modes are 1, 3, 4, and 6. So this would be technically called multimodal. Multimodal. But when we have 6 categories and 4 of them are modes, all tied at a frequency of 5, multimodal doesn't really tell us much about the graph, or about the distribution. So when we have this sort of distribution, we tend to call it uniform. This is called a uniform distribution. Okay, so we'll keep going with this party scenario on the next graph. So we'll call this one number 2. Alright, so our frequency axis is going to be people again. And for a variable axis, let's call this, well, water would make it kind of a lame party, so let's just call it drinks, right? Drinks. Okay, so we'd interpret this tallest bar here as 8 people took 3 drinks. Okay, so let's undo those. And to find our symmetry, we have to look at our range again. So our range here is going to be 6 minus, and notice that we don't have any observations here. There's nothing there. So we're going to call this, our first observation occurs at 1. So our range is going to be 5, right? So if we have this again, we have about 2.5. Now it's important to remember that this is categorical data, so kind of dropping a line of symmetry here doesn't really make much sense. So we can round up. Let's round up and draw a line of symmetry here, right down the 3. Okay? So we're going to call this symmetrical. Symmetrical. Okay? And how about our mode? So our mode here is pretty clear, right? We've got a clear tallest bar. The mode occurs at, well, let's call this modes. Well, we only have 1. Our mode occurs at 3 with a frequency of 8. Okay? So this sort of distribution, where it only has 1 mode, is called symmetrical and unimodal. Unimodal. And so if we take a look, if we just kind of trace out this sort of graph here, connecting all the middle parts of each bar, well, this is pretty rough, sorry. So let's try to make that a little bit better. So this is a pretty rough graph, but if we do this, we see that it kind of takes on a bell shape, right? So for that reason, symmetrical and unimodal graphs are often referred to classically as bell-shaped. Bell-shaped distributions. Okay, so moving on to one more kind of distribution here. So we've got this one here on the left, we'll call this number 3. And with our usual process, we can kind of decide that we want to draw a line of symmetry down here at 3. And we can see that we have 2 modes here. We've got one here and one here. We've got 2 peaks, twin peaks. Great show. All right, so we can draw out something like this. So let's connect the tops of the bars again, pretty roughly, just so you can get an idea of the shape. There we go. All right, so our modes here are 1 and 5. 1 and 5. And we can decide that, hey, it looks pretty symmetrical to me. So let's call this symmetrical and bimodal. So this is a symmetrical and bimodal distribution. Okay, so on the right here, I wanted to cover a mistake I often see, so we'll just go ahead and call this number 4. Okay, so this histogram again has some symmetry. We can draw a line right down the middle, and we see that it's fairly symmetrical on each side of the line. Okay, but determining modality is a little bit trickier, and this is something I still remember getting wrong on my very first AP Stats exam. So it looks like we have one clear mode here at 1, right? It's the tallest bar in the histogram by far. So we'd be tempted to call this a symmetric and unimodal graph, right? Symmetric we know for sure, but if we called this unimodal, we'd in fact be incorrect. So when looking at a graph, our modes are our local maxes. Local maxes. So this is probably going to cause some unwelcome flashbacks to maybe Algebra 2 or pre-calc, maybe even calculus, depending on how far you are in math. But let's call this our local max. Okay? So if we trace out the shape here, we can go from here to here and keep kind of connecting the middle of the bars together. So we've got a peak here at 1, right? And we got another peak here, well, kind of offset, but this peak here at 5. So we've got a local max here and another local max here. Now 1 is our global max. So this is our global max, which means it's the maximum point on the distribution over the entire graph, this whole graph here. Okay? So 5 being another local max here at the top of this little crest means that we actually have our local max at 1 and 5. So this is a symmetric bimodal distribution, just like the one on the left. Okay, and the whole point of showing this example is when we take a look at this one, number 3 again, we see that this value here is at frequency of 6, and so is this one, right? Whereas this one is at a frequency of 6, and this is a frequency of 5, at bar 5. So you'd be tempted to say again that this is a unimodal graph, and this is not a maximum at all, but in reality it's a symmetric and bimodal distribution. Okay, so let's take a look at skewed graphs here. So skewed graphs are unimodal graphs. They're unimodal graphs that cluster on one side and have tails off to the other side. So the important thing to remember here is that they are defined by their tails. So let's take a look at these red graphs on the left side. Okay, so we can see that they're clustered kind of to the right over here, and they've kind of got, if we drew this quick little shape here, they've got tails off to the left, right? This is a tail. Okay, and we call these left skewed. Left skewed or negative skewed. I'm just going to call this negative. Okay, and that's because the tail happens to come on the negative side of the distribution, whereas this would be the positive side. And I included these box and whisker plots here too. So if we take a look at this, well, we'd be mixing metaphors if we called the whisker of the box plot a tail, but this is off to the left. So again, this is a left skewed graph. So the blue graphs on the right side here are kind of the opposite. So let's draw this shape again. Right? So in this case, the tail off of the distribution happens on the right side. And the tail of this is longer than this tail here. So we'd call these right skewed. Right skewed distributions, or positive skewed. Okay? And so on the center, these green graphs here, these center graphs, if we drew these shapes, they're perfectly symmetric to the best of my drawing ability, and these are pretty much equal, so we call these normal. These are normal distributions. Well, normal distribution comes up quite often in probability, but as we're dealing with univariate data right now, we just call these normal or symmetrical. And that covers it. That should be pretty much what you need to know when you're interpreting univariate histograms, univariate box plots, and in terms of figuring out what type of distribution it is, whether they're symmetrical, unimodal, bimodal, and if they have any sort of skew.